Channel and now answering question number 7 from the October 2024 Mechanics M1 International A-Level Edexcel paper. And this question is the last paper on this, or this question is the last question, on this paper. It says on time t equals 0, a small ball is projected vertically upwards with speed 8 meters per second from a fixed point on horizontal ground. The ball hits the ground again for the first time at t equals t1 seconds. Ball A is modeled as a particle moving freely under gravity. Show that T1 is 1.63 to 3 significant figures. So you have horizontal ground. You have the horizontal ground here. And let's call that level O. So the ball is projected upwards. The ball is projected upwards. It reaches its maximum height vertically, and then it comes down. I'm not saying that, it's projected vertically upwards, it comes down, and then it hits the ground again. So when it's projected upwards, it's projected with a speed of 8 meters per second. It's projected with a speed of 8 meters per second. Okay, so this is 8 meters per second upwards. And that's all we know. Okay, so we know that in this, of course, is falling freely under gravity, or is thrown freely under gravity. Okay, it's moving freely under gravity. There's no air resistance, so you got G acting vertically downwards. Now I'm going to use the Suvat equations, and as it was projected upwards, I'm going to take upwards positive. Right? So S would be 0 because we want to find for it going from O back to O again. Okay, so S would be 0. The displacement S does not stand for the ground or the distance that is covered. It doesn't stand for how much distance travel this way and then how much distance it travels that way. S is the displacement, means how far out of place it is from its initial position, from what we've taken as the initial place. We've taken the initial place as O, and we want to see how long it took to go up and then back down to O again. So our displacement is going to be 0. Our initial speed is going to be 8. Now, because it's going back to the same level again, and there's no air resistance or anything, the final speed will also be 8, but in the opposite direction, in the direction that we are calling negative. So that's going to be negative 8. The acceleration is going to be G, positive G, because, negative G, because we're taking down as upwards positive. As we're taking upwards positive, G is acting downwards, so it's going to be negative. And T is, it's going to be T. We'll call it capital T for now. All right? Now, so we'll call it T1, as they told us to call it. So we have two options here. If you didn't realize V was minus 8, then you could have used S equals UT plus a half AT squared, and you would have got a quadratic equation, and you would have got two solutions. One of them would be T equals 0, and the other one should be T equals what we found. We'll have to find. Or because we know that it's going back down at the same speed at which it left, but in the opposite direction, because there's no air resistance or anything like that, then we can take V as negative 8, in which case we have a very nice, easy formula. V equals U plus AT. So V is negative 8, U is 8, A is negative 9.8, and T is T1. So we end up with 16, negative 16 over negative 9.8 is equal to T1. So T1 is equal to, take the calculator out, hopefully the answer that we're supposed to get, negative 16 over negative 9.8. That gives us 80 over 49, which is what we have to find. 80 over 49, which is as 1.632, which is 1.63 to 3 SF, as required. So T1 is 1.63 to 3 SF. Okay. As I mentioned, there's an alternative way of doing this. If you didn't realize, okay, if you didn't realize that V was -8, for example. Or if it was a case where we're finding where it's going to be at a level where we don't know what the velocity is going to be, somewhere not back to the original place again. Then we can use S equals ut plus 1/2 at squared. I'll show you how that works. So S is 0 again, U is 8, T is T1. Let's call it T because then we'll have two different T's. Plus 1/2 times 9.8 times T squared. Okay, so you end up with basically, there'll be 4.9 T squared plus 8T equals 0. So you end up with T times 4.9 T, okay, plus 8 equals 0. Oh, this is minus, this will be minus 1/2, sorry. Let me do that again. That's what happens when you do things in a rush. A is negative G, right? So we have 0 equals U, which is 8, and you have T plus 1/2 times minus 9.8, because A is negative G, times T squared, right? So you end up with basically 8T minus 4.9 T squared, because 1/2 times 9.8 is 4.9, equals 0. So you got T, and then you have 8 minus 4.9 T is equal to 0. So T equals 0, or you end up with T equals, if you have 8 over 4.9, and 8 over 4.9 is exactly what we just worked out, I think. 80 over 49, which gives us 1.63. So of course it's 80 over 49, which gives us 1.63. So what does the T equals 0 represent? That represents the time when it was first projected. It was at that same level, beginning. And then it reached that same level again on the way down after it had fallen. So you get the same answer. If you didn't realize V is -8, you can use S, U, A, and T. Okay, so there's the answer to part A. All right, now for part B of this question, we have to go down here and see what it says. It says, after the first impact with the ground, A rebounds to a height of 2 meters above the ground. Given that the mass of A is 0.1 kilograms, find the magnitude of the impulse received by A as a result of the first impact with the ground. So we got to take the situation now from this place over here, okay, where it hits the ground. Okay, so we're going to focus on now the part where it's moving down, it hits the ground, and it rebounds back upwards. So it's basically, it's going downwards, okay, at a speed of 8 meters per second. So that's the speed with which it's going down. Let me get the pin back. So it's going down with a speed of 8 meters per second. Okay, and I'm going to focus on it like a particle. This is 0.1 kilograms. It hits the ground and it rebounds back up. So it rebounds upwards. And we need to know what that speed is. We need to know what that speed is. Okay, so we don't know what that is. If I know that speed, I can work out the answer, because I'm going to find the magnitude of the impulse received by A as a result of its first impact with the ground. So what changed its motion at this point? Well, the impulse it received from the ground. So that impulse is going to be acting upwards. Okay, and that's what's caused its change of motion. So the impulse is always given by the mass times the change in velocity. It's basically the change in momentum of the object. The momentum at the end minus the momentum in the beginning tells you the impulse that was received by an object. So basically, the U in this case is this. Okay, now I'm going to take, in this case, down as positive. Why am I taking down as positive? Because initially it's moving down. That's what I'm going to do. Well, you have to have your direction sorted out. It doesn't matter if you take up or down. It really doesn't matter. I'm just sticking to my own convention that I use in all mechanics problems, that the direction that something is initially moving is the direction that you take as positive. That's how I like to deal with things. So I'm taking down in positive, I will take down as positive in this section where I'm finding the impulse. So in that case, I know the value of u is 8 meters per second, and I'm going to take it as positive. And the value of v here, okay, the v in this case, which is this v here, is something I need to find out. How do I find out that v? And of course, I know m is 0.1 kilograms. How do I find out that v? Well, they told us that after the first impact with the ground, this object rises up 2 meters. So its vertical height that it reaches due to acceleration, due to gravity, it's going to be decelerating as it goes up. That's 2 meters. Okay, so I'm going to consider now from O to this point, which I'm going to call P. All right. Now, when I'm considering from O to P, in this part, I'm going to take up as positive. Why? Because between O and P, it starts moving upwards. Okay. And I know that it's falling free. It's like subject to, gravity. All right. It's acting freely under gravity, basically. So there's no air resistance or anything like that. So there's constant acceleration, which is the gravitational force acting downwards. So I'm taking up as positive. So S equals 2. U equals what we're trying to find. Okay. Which, what should I call it? I'll just call it V dash. I call this V dash, right? Which is the velocity in this situation. Okay. My final velocity is 0 in this situation. It reaches 0 meters per second. Okay. And this is like our V dash. We don't know what we have. This is what we're trying to find. Acceleration. Now we're taking up as positive. It's acting down. So it's minus G. And T we don't know. So here we can use V squared equals U squared plus 2AS. In this case, our V is 0. Our U is what we're trying to find, V dash. Okay, V dash squared plus 2 times minus 9.8 times S, which is 2. Okay, so that will help us now find the speed with which this left the ground. So we got here V squared is equal to, that's 4 times 9.8. Yeah, 4 times 9.8. That gives you 196 over 5. Okay. That's 196 over 5. That's V squared. So V is equal to the square root of 196 over 5. I'll leave it like that for now. This is the velocity with which it leaves the ground. So now what we have is a situation where I can use from O to P when I can use the momentum. So I know the impulse is equal to the mass times the change in velocity, which is the change in momentum. So the mass is 0.1 kilograms. And now I'm taking down as positive. So my U is going to be 8 and my V is going to be negative. Okay, is going to be negative the square root of 196 over 5. Okay, that's going to be the velocity that's going up. So it's negative. I'm taking down as positive here. All right, so your impulse is going to be mass, which is 0.1, times negative root 196 over 5, okay, minus U, which is 8. Okay, okay, and that's my answer going to be, therefore, you're going to have, where is it? Okay, so you have the square root of the answer, okay, which is 14 root 5 over 5, so that's negative, minus 8 times 0.1. That gives you negative 1.426, negative 1.4260. So the impulse, the magnitude of the impulse received by A, or by the, is it called particle A? Yeah. Received by particle A is equal to 1.43 Newton seconds impulse is given as Newton seconds. Okay, so there's the answer to part B. I think it might have been wiser for me to have left this in terms of G actually, but still fine. This would have been basically V squared equals 4G, right? So V would be the square root of G times 2 root G. Okay, but it's no problem, it's the same thing. In the end, you can put 9.8 there. Anyway, so there we have the answer to question number 7, part B. Okay, so we've got the impulse that A received as it hit the ground. So we needed to find the speed after the impact, which should be found by the fact that it rose up 2 meters, and then we could find the impulse that it received. So don't ever write the impulse as a negative value. If the question says magnitude, you just write down the value that you got. If the question asks you for the direction of the impulse, you just think about how the object was moving before and how it was moving after. It was moving down before, and after it's moving up, so the impulse must have acted upwards to change its motion. If it was moving in a certain direction and it slowed down in that direction, the impulse would have obviously acted in the opposite direction as well to slow it down. So the impulse always acts in the direction that causes the change in the motion of the object. Okay, so there's number 7, part A and B. Is now for part C. It says at time t equals 1 second, another small ball B is projected vertically upwards from another point on the ground with speed 5 meters per second. Ball B is modeled as a particle moving freely under gravity. At time t equals 2 seconds, at time t equals t2 seconds, where t2 is greater than 1, A and B are at the same height above the ground for the first time. Find the value of t. So basically, you have a situation where they're both projected from the point O. A is projected first, and then B is projected 1 second later. T equals 1 second. So A is projected, as we know from the first part of the question, with a speed of 8 meters per second. And B is projected, as we've just been told, with a speed of 5 meters per second. Okay, eventually they're going to reach the same height. What happened before that, we don't really need to know, but what we need to understand is that they both reach the same height. Okay. Let's say the height is over here. Okay, and that height we're going to call it, let's call it X. Okay, that's the height that they both reached. So let's call that height X. So that fluffy around here. Okay, so the height they both reached, let's call it X. Okay, so they both reached that same height at time equals t2. Okay, at the same time. Now, we're going to consider A and B, and we're going to consider their situations separately. Okay, I'm going to take for both of them up as positive, as they were both projected upwards. Okay, we know for both of them you have the acceleration due to gravity acting downwards. So if we consider the displacement at the point where they reach X, well, it's going to be the same displacement. That's what's going to help us connect these two together. So call that X. The initial speed of A is 8. The initial speed of B is 5. The final speed of A, we don't know. The final speed of B, that means the speed at this point, we don't know. Call it VA and VB. The acceleration for both of them is minus G. That's acting down on both of them. And the time, this is where we got to think a bit. Okay, so what I'm going to do is, we know that the time t is time after, t is defined in this question, okay, as the time when A was projected. Okay, so t2 would be the time that A would be in the air. Okay, B was projected 1 second after A, right? So here's where you have to be careful. That means the time that this has been in the air is 1 second less than A. So this is the time that A has been in the air. B was projected 1 second later than A. So it's been in the air 1 second less than A. And this is where people mess up. So if you think about it, if A was projected and, it's been in the air for 3 seconds, B was projected 1 second later, it's been in the air for 2 seconds only. So you don't put +1 here, you put -1 here. Very important. T2 is defined as the time after A was projected. T in our question here is the time after A was projected. Okay, so T2 is the time that A has been in the air. Okay, and the T2 minus 1 is the time that B has been in the air. Okay, so we have to be very, very careful about that. Now we've got S. We're going to deal with S, U, A, and T for both of them. So we're going to use the formula S equals UT plus a half AT squared. So we can consider for A, we're going to have X equals U times T, so it's 8 times T2 minus or plus a half times minus G, so it's going to be minus a half G. Why? Because A is negative G, so it's going to be negative a half times, it's a half times negative G, negative half G times T2 squared. And this is for A. For B, we're going to have X, same height, same displacement that is reached, equals 5 times, and this time here is T2 minus 1. And you're going to have plus a half times minus G, so it's minus a half G, and then again the time is going to be T2 minus 1 squared. So what I know is these two things are equal to each other. Okay, these two things are equal to each other. So what I can do here is I can just equate them. I can say 8T2 minus a half GT2 squared is equal to 5T2 minus 1 minus a half times G times T2 minus 1 all squared. And then I can expand these and simplify and solve. So 8 times T2 minus a half GT2 squared equals 5T2 minus 5. And this is going to be minus a half times G times, I've got to expand this bracket, that's T2 squared minus 2T2 plus 1. Okay, so let's just, I can start simplifying some of this. So I can say, for example, 8T2 minus 5T2 is 3T2. And then I'm going to have minus a half GT2 squared equals minus 5. I've kind of dealt with those two and became 3. Minus 5, and I can expand this bracket. So I've got minus a half GT2 squared, and minus a half times minus 2 is plus the half and 2 cancel, GT2, and then minus a half G times plus 1 is minus a half G. Okay, so now minus a half G2T squared cancels out because they're both the same on opposite sides. So if I bring them together, they'll become 0. And I've got here 3T2, and I've got a T2 term here, so I'll bring that on this side. So 3T2 minus GT2 is equal to, I've got minus 5 minus a half G. Okay, now I could replace G with 9.8 here, I guess. Or I can leave things in terms of G. Let's do that and put G in as 9.8 at the end. So what I can do here is I can see T2 is common, so I can take T2 out. And I've got 3 minus G, and I've got minus 5 minus, I'll put it as decimal 0.5 G. And now I can divide both sides by 3 minus G. So I have T2 is going to be, I'll divide both sides, so minus 5 minus 0.5 G divided by 3 minus G, and that will give us our answer. So let's put this in the calculator. We have minus 5 minus 0.5 times, and I'll put 9.8 now as G, divided by 3 minus 9.8, and that gives us 99 over 68. That's 99 over 68 seconds, which you can write to 2SF or 3SF. So let's see. Where's the calculator gone? Here it is. So we can write this as 1.4, 1.5 if you wanted to, or 1.46. So it comes out as 1.4558, 1.4558. So we could write the answer like this, or we could write the answer as 1.5 seconds, or we can write the answer as 1.46 seconds. I normally would stick with the 3SF version, but all of those three would be correct answers for this question. And that concludes this question here from the October 2024. This is the M1 paper for Edexcel International A-Level. Other questions from this paper can be found in the playlist that will appear in the top right of the screen. Other questions from the topic of vertical motion under gravity and SUVAT type of questions, you'll find them in the playlist over here. You can subscribe to my channel by clicking on this link. And the video at the top here will show you how to use my channel to find those things you might be looking for. Thank you for watching and see you soon.